Unit 6, Section 3. Here we have examples C and D. So this is when we're going to start to play with 3 dimensions. So we have similar rectangular prisms, A and B. So first, what's the scale factor? Well, for the scale factor, I'm just going to look at one side versus another, the most simple way we can do it. Let's see, I'm going to decide this is my new one, and this is my old. So let's say I was shrinking them. So if I go, once again, if I'm going from this one to this one, I'm getting smaller, so I should get a fraction, something less than 1. Let's make sure I do. So I do new over old. I could do 5 over 25. Or keep in mind I could also do 16 over 80, which as long as I have those corresponding sides. Or, you know what, I could have done 3 over 15. Any of those work. And luckily, if I check, all of those simplify down to 1 over 5. So that is my scale factor. It's less than 1, which makes sense because I'm shrinking. And so it asks, what is the surface area of each figure and how do they compare? So how do those scale factors compare? Now I'm going to guess that since I'm doing area and that's in 2 dimension, it's going to be k squared. So I'm going to guess it's going to be 1 over 25. But let's solve it and see what we get. So if we have surface area of A, now remember the surface area, there's a formula. I always just remember you have to find the area of each side and then each side multiply it times 2. Because you think about, well, let's say I was going to do 5 times 16. So that's that front piece, but then I need the back piece is the same. So I need to do the front and the back. And then if I was going to do the bottom of 16 times 3, I know I need to do the top and the bottom. So those two, and then add that to the left side and the right side, which is going to be, they're both 5 times 3. So let's see, I'm going to get rid of this arrow so I have a little more room. And if you plug that all into your calculator, so you get the answer of 286. And that would be in units squared, square units. Do the same thing for B. So let's see, if I was going to do front and back, I would do 25 times 80 twice. And then if I was going to do the top and the bottom, I would do 80 times 15 twice. And then if I was going to do the left side and the right side, I'd do 15 times 25 and do that twice. If you plug that all in, you're going to get 7,150 units squared. Here I already wrote it as new over old. So it would be 286 over 7,150, and I can actually simplify that down to 1 over 25, which is exactly what I wanted, k squared. And what's the volume? Once again, I can kind of predict it's probably going to be k cubed, because volume is in 3 dimensions, and we've kind of figured out that relationship of k and volume being k cubed, but let's just double check. So we have the volume of A, which remember is length times width times height. So that would be 5 times 16 times 3, which we get to be 240. And the volume of B, which we get to be 25 times 80 times 15, which is 30,000. Put new over old, and we can actually simplify that down to be 1 over 125. And if you're confused about how to start simplifying, I always start with, well, this one I can get rid of a 0 on the top and the bottom, so divide both of them by 10. And then you just kind of go from there like, oh, they both have a 2 in common, so I can do half of each. And you kind of keep going until you get, 1 tells me I'm definitely done on top. Or if you can't think of any other numbers that go into that, no greatest common factor, or just factors at all that go into that, then you know you're done simplifying. And this also equals k cubed, because we think of 1 over 5 cubed, and 5 cubed is 125. So the last thing is here in D, it's asking us what conclusions can we draw? Well, we've really been alluding to it this whole time. But just so we write it out so it's really clear, when things are in 1 dimension, like length of one side, or the perimeter, so the distance all the way around, adding all the lengths, or even if we do something like circumference, then our scale factor is just k. If we have something in 2 dimensions, so something like area, or like surface area, those types of things, our scale factor will be squared, so it'd be k squared. And then when we do something in 3 dimensions, like volume, we have k cubed. Those are how all of the scale factors relate to one another. Stay tuned in the last video for the last 3 examples.